Hello students, welcome to this session. I have just solved this JEE main test 77 and here I am with the analysis of the paper. So paper is not a tough one. I have regarded only one question as tough, 15 were medium, 9 were easy, and for the question number 5 I suppose they have given the wrong answer. So it wasn't a difficult paper. It should be scoring 1. Anyone decent in physics should get 60 marks, and for the good students it should be 80 plus paper that I can feel. Now question number 1. For sodium light, the two yellow lines occurs at lambda 1, lambda 2 wavelengths. If the mean of these two is 6000 and the difference is 6, so difference is very small, that means they would be very near, then the approximate energy difference between them is. And looking at the options are far away, so what I can make out, I know energy is hc by lambda, so for a small difference, the difference I can write as, I can directly write dE, or you can say dE would be equal to hc by lambda square d lambda, magnitude of d, that negative sign I am ignoring. So if I do this difference, because this d lambda is very small and I will take the mean to be 6000, so it would be 1240 upon, I am writing in EV nanometer it is 600 into 600 I can write, and d lambda is 6 angstrom, means I can write it as 0.6 nanometer. So what we have now, this is 00, so 124 into, if I do this would be 100, so 124 upon 6 into 10 to the power 4. So it is 1.24 by 6 into 10 to the power minus 4, or 12.4 into 10 to the power minus 3, that would be 2.0 something into 10 to the power minus 3 EV. So I'll go for option A in this particular case. Because the difference is very small, I can do this. Otherwise you can do by complete calculation, as the NTA solution I am seeing has done it. Now the particle moves in the xy plane under the action of a force F such that the coordinates of its linear momentum at time t is this and this. So px py, you can directly make out that p is constant. That means p, the magnitude of p is constant here, the magnitude of p is constant here, that means the speed is constant here, speed is constant here, so therefore you can say work done will be 0, or you can directly say f dot v is 0, so f dot p is equal to 0, that means angle is 90 degree, because 2 cos t 2 sin t, the magnitude is always 2, directly you can go for. Next, so here the third one, for the arrangement in the figure, the particle m1 is attached to an end of a string which moves on a horizontal table in a radius l by 2 with speed omega. The other end is attached to mass m2 here, that is what we are given, it is attached to m2 which rests on a vertical rod. When the rod collapses, the acceleration of mass m2 at that instant is. So here, as soon as this collapses, the tension will also change, and I can know this will go with acceleration a here, and it will have some acceleration a here now in the frame of what we can say the table. So in the frame of table, if I work at just this moment, the speed was omega square and it was going in circle, so I can apply this pseudo force m1 omega square l by 2, this would be t, here it would be t, and here it would be m2g. So just applying in frame of that, what we will have, m2g minus t is equals to m2a, this is my first equation, and t minus m1 omega square l by 2 equals to m1a, this is my second equation. So what I get now, so if I do the acceleration, add up, it would be 2m2g minus m1 omega square l upon 2 equals m1 plus m2a. So the value of a is 2m2g minus m1 omega square l upon 2 times m1 plus m2. Now search for the options. Search for the option, I think this one is C. So we'll go for option C here. So it's a nice one. Just remember, you cannot write tension equal to m omega square l by 2. That was just before it collapses, because the tension of the string can change instantly. That is an important thing. Spring's tension doesn't change instantly, but the string's tension can change instantly. Next, in an experiment, according to setup, when E1 is 12, okay, this is 12, internal resistance 0, small e is 2, we'll assume internal resistance to be 0, I suppose. The galvanometer reads 0, then X would be. So galvanometer is reading 0, that means if I consider this point to be grounded or 0 potential, this would be E means 2 volt, and if no current is flowing, that means this is 2 volt, and this means this is, we know, just 12 volt. So what I can make out, the current through this will be completely diverted, this is I0, this will be the I0. So what I'll have there, what we can say, these both are basically, what is the value of I0? I0 would be 10 upon 500, and that would be equal to x upon 2. So x comes out as 20 by 500. I can make out x comes out as, if I'm wrong, this is 10 by 500, this is x by 2, so it's come out as 20 by 5. Okay, I have done something something. Let me check. Current is 10 by 500. This is 2 by x. Okay, I've written this wrong. It would be potential difference 2 by x. So x would be 500 into 2 by 10. That comes out as 100 ohms. You could directly go by the ratio also. So this is C. So option C is the appropriate one here. Next. If a small sphere of mass m and charge q is hanged from a silk thread at an angle theta with the surface of vertical charge plate, then for equilibrium of sphere, the surface charge density of the plate is. So let's say this is the plate, and because it is conducting, and let's say it is being through like this, let's say this is positively charged. So what we have, this QE force will be here, and E, because of conducting plate, you know, is equal to sigma by epsilon naught. Because of the non-conducting one, you did typically write it as sigma by 2 epsilon naught. Here what we can write it as sigma. Just remember, if it would be non-conducting, it would be sigma by 2 epsilon naught, but for conducting we write it as sigma by epsilon naught. And we have this mg and we have this tension, so this angle be theta. So now what you can do, you can write for vertical balance T cos theta manages mg. For this, T sin theta equals q sigma by epsilon naught. So dividing them, what we'll get, tan theta is sigma q upon mg epsilon naught. So the value of sigma comes out as mg epsilon naught tan theta by q. So this comes out as option A. They have given answer as B, which is not right. That would be right if it was also a non-conducting plate. Next. Two thin rings, each of radius r and are placed at a distance d apart. The charges are plus q minus q. The potential difference between their centers is. So let it be A, let it be B. So potential at A because of own charge would be kq by capital R, and because of the nearby charge would be minus kq upon under root of r square plus d square. Now at the center of the negative one, it would be minus of kq by r plus kq upon under root of r square plus d square. So if I do the difference, VA minus VB, it would be 2 kq by r minus 2 kq upon under root of r square plus d square. So going by the options, what we will have now, so going by the option, k is 1 upon 4 pi epsilon naught, 2k L common, so it would be option B. If you do this, this is option B, that is correct here. Next. Given below are the equation of motion of 4 particles A, B, C, D. This is this. Okay. The particle with constant acceleration, you know, would be t square function. So xb, if you do this, this is constant acceleration. Also A also, because its acceleration is 0. And what we have D also, because its constant, its acceleration is also 0. So the particle moving with constant acceleration is, typically it is ABC, but because it is asked for constant acceleration, for the most appropriate one I will go for B, because that has a non-zero acceleration. Otherwise here also they are not accelerated, so yeah, B is more appropriate, because A and C typically, A and D typically you will say are not even accelerated. Okay, though you can say acceleration 0 is constant. Next. A small planet is revolving around a very massive star in a circular orbit of radius r with a period of revolution t. If the gravitational force between the planet and the star is proportional to r to the power minus 5 by 2, then t will be proportional to. Same question was in NEET paper today. So what I can say, the force, let's say it is k upon r to the power 5 by 2, that is equal to m omega square r. Omega is 2 pi by t whole square divided by r. So what we get, t square is proportional to r to the power 5 by 2 plus 1, that is 7 by 2. So t is proportional to r to the power 7 by 4. So I'll go for option C here. This is a common question being asked in this style. Next one. A cylindrical rod with one end in a steam chamber, okay, that is 100 degree, and the other end in ice results in melting of 0.1 gram of ice per second. The rod is replaced by another with half the length, double the radius, and if the thermal conductivity of second is 1/4 the rate at which it is. Okay, so just check the resistance first. For the first rod, you can say resistance, thermal resistance is, let's say, L upon K. Now for the second one, you have length is half, so it would be L by 2. You have thermal conductivity as 1 by 4, so 1 by 4 K, and double the radius. Double the radius means it would be 4 times the area. So it would be basically L upon 2K, or you can say R1 by 2. So if resistance is half, heat flow will get doubled, so the amount of ice melted will also get doubled, so that would be 0.2. Next. Ideal gas heat engine operates in a Carnot cycle between these two temperatures. It absorbs this at the higher temperature. Amount of heat converted into work is, so efficiency is W upon QH, that is 1 minus TC by TH for Carnot. So W will be QH is 6 in 10 to the power 4 into 1 minus TC. TC is 127, that is 400, and this is 500. So 6 into 10 to the power 4, this comes out as 1 minus 4 by 5, that is 1 by 5, that is 1.2 into 10 to the power 4 joules. So go for option B for this particular question. This is B. Next, the quarter disk of radius r has a uniform charge density sigma. Okay, find potential at a point 0, 0, z. Where is 0, 0, z? It would be here. So we can say because 0, 0, z, the complete formula that we use for disk can be applicable because all the four halves produce symmetrically. And if you remember that electric potential formula, I doubt how many of you actually remember, but let me redraw it. Let's say go by at any x and take it as dx, and or a small r dr, you can write it, that would be better. So the charge dq that you will write is sigma into dA. dA, what you can write it as sigma into dA. dA would be, what you can write it is pi r dr. What you can say, this is 2 pi r dr. So here the length is not 2 pi r, it is only pi r by 2, pi r by 2, small r by 2 into dr. So this is the charge. So the potential due to this dV, you will say is k dq by distance. Distance would be under root of r square plus z square. So it would be sigma 1 upon 4 pi epsilon naught sigma pi r dr upon 2 under root of r square plus z square, and for complete you will do integration from 0 to r. So if you do this, this pi goes, this 1 upon 8 epsilon naught, and this sigma terms comes here. Now what we have, r dr upon under root of r square plus z square. So you can take it like taking this r square plus z square is, let's say, some, what you can say is t. So what we have is, let's say, t square, was the thing something like this. So 2r dr is equal to 2t dt. I think you can write it like this. So what will become, r dr is t dt, so it becomes t dt upon, what we can write, t dt upon t terms. So it would be a very nice one for you. It will cancel up, and the limits would be z to z square plus r square. So that's an easy one for you. So it is sigma upon 8 epsilon naught, and it would be under root of z square plus r square minus z. So what we will left with, option C. So it's a calculus based question for you. Next, the trajectory of a projectile in vertical plane is this. Are constant are respectively horizontal and vertical distances from the point of projection. Maximum height attained and the angle of projection is, again, this is a very common one. So maximum height attained, that would be when dy by dx is 0. So that is 0 means a minus 2bx equal to 0, that is at x equal to a by 2b. So at x equal to a by 2, that is y max. Y max we get is a into a by 2b minus b into a square by 4b square. So it comes out as a square by 2b minus a square by 4b, that is a square by 4b. So we are left with two choices, and the angle. And the angle that you compare by the standard result x tan theta, so tan theta is a, so it is tan inverse a. So go for option C directly by comparing it. Next, radioactive sample, half-life 10 days, contains 1000x nuclei. Okay, number of original nuclei present after 5 days is, so what will happen after 5 days is, so what you will say, n would be n naught upon 2 to the power t by t half, that you remember. So n naught is 1000x, 2 to the power t by t half is 5 by 10, that is 1000x upon root 2, and root 2 is 0.707, so it is 707x. You can directly go for, you remember this one, by root 2 is 0.707 we write. Next, we have a wire of length L, diameter d, density rho, stretched under a tension T. Correct relation between fundamental frequency, this, you know, F is V by 2L, V is under root of T by mu, mu is rho times A upon 2L. So what we will have, area is proportional to D square, so what we have, F would be inverse to D and L. So F would be inverse to D and L, so we will go for option C here. Next, surface tension of a liquid is S, work done in increasing the radius of soap bubble from S to 3R. Okay, it should be R to 3R, I suppose. There's a printing mistake, I suppose it is R to 3R. So what we'll say, W is delta U is S delta A. So what is S delta A? Initially, finally it would be, we write 8 pi r square. So because of the doubling of the two surfaces, 4 pi r square plus 4 pi r square into 3r whole square minus 8 pi r square. So it is 9 8 is 72 minus 8, that is 64 pi r square s. That is what we will have, and I think same question we have done some days before. Next, I can be regarded as a single refracting surface. The radius of curvature at this surface is equal to that of cornea. Surface separates two media of these refracted indices. Calculate the distance from the refracting surface at which a parallel beam of light will come to focus. So just apply the equation n2 by v minus n1 by u equals n2 minus n1 by r. So u is infinity, n2 is 1.34 upon v is 0.34 upon r. Let's say 7.8, it will be positive because we know it is like this. So the diagram will be something like this. Also remember, this is millimeter, so be careful about it. So v comes out as 1.34 into 7.8 millimeters upon 0.34. So if I convert it into centimeter, it would be 1.34 into 0.78 upon 0.34 centimeters I can go for. So it's approximately 2 point something, and 1.3 into 2 point something, it would be definitely greater than 2.7, 2.8. So as per the option, it cannot be 4, it would be 3.07. Complete the calculations, you will get it. Next, a uniform thin spherical shell and a solid cylindrical roll horizontally without slipping. Okay, speed of the shell is v. Solid in the hollow cylinder encounter an incline that they climb without slipping. The maximum height they reach is same. Find the initial speed. So because they are undergoing pure rolling, so we'll say the complete energy will be transformed. So what we will have, half mv square beta would be equal to mgh. So if h is same, it means if h is same, this means v square b must be same. So v square b must be same. For the cylindrical shell, we can have v of the shell square into beta. Beta for the shell, you know, is 1 plus k square by r square. That comes out as 2, sorry, because it is of a ring, so it is 2. Beta is 2. That factor beta, you just remember, I am always using this. It is 1 plus k square by r square. K is the radius of gyration about the cm axis. And for the solid cylinder, it would be v solid into like the disk one, that would be 3 by 2. So clearly v solid square, v solid you can say would be v of shell into under root of 4 by 3. You can make it out. So what we have now, as per the option, this goes for option A here. Next, for a given logic diagram, the output f is equal to 1, then inputs are okay. So when it would be 1. So for this to be 1, this is AND gate, so here has to be 1, so C has to be 0. So we are left with these two choices. And what is this? This is an OR gate. So 0 0 won't give us 0, 0 and 1 will give us 0. So 0 1, this will be 1 1 1. So we'll go for option B. That's an easy one, not a tough one for you. Just get the right combo. If unit of length, mass, time each be doubled, new unit of work done is, you know, work done. If the dimensional formula, I know it is ml2t minus 2. I always say force and work, you remember these. Now each is doubled, so m is doubled 2 times, this is 4 times, this is 1 by 4 times, so it would be doubled, so new unit of work would be 2 times. Next, two identical piano string length this tuned exactly to 500. If the tension is now increased by 21% in one, what is the beat frequency? So what will happen? We know f is proportional to v is proportional to root t, so new f dash upon f would be 21%, that it would be 121 by 100, that is 11 by 10. So new f dash is going to be 50. 50 means it would be 11 by 10 into 500, that is 550. So now the beat frequency would be 50. That's another thing, you cannot hear a beat of 50 hertz, but since the option is giving it is 50, ideally you won't hear any beat, because after 10 12 15 beats we can't, our ears cannot recognize that. Next, two blocks of equal masses are released from the incline of 45 degree. Both blocks are at rest. Static coefficient of kinetic friction is 0.2 for A and this, and 0.3 for B. Initially A is root 2 meter behind. At what time will their front faces come in a line? This is a standard question, I suppose, probably come in some JEE previously subjective one. So what we'll have here? So I see the situation with respect to B. So for that to come with respect to B, displacement of A with respect to B must be equals to root 2 meters. Initial velocity of A with respect to B is 0. Acceleration of B with respect to B would be A minus AB. And acceleration on the incline, you know, is known as g sin theta minus mu k g cos theta. So if I subtract it, it would be negative sign, so it will become mu b minus mu a into g into cos of 45. So mu b minus mu a, that is 0.1 into, let's say, 10 into 1 by root 2. So this also comes out as 1 by root 2. So you have to find the time. So acceleration remains constant. So apply the second equation. So root 2 is 0 plus half into 1 by root 2 into t square. So t square comes out as 4, t comes out as 2 seconds. So this answer is going to be 2. So time period this time is 2 seconds. Next, this is the vernier. Okay, after many days I am seeing this vernier. The main scale of a vernier reads in millimeter, and the vernier is divided into 10 divisions, which coincides with 9 divisions. That is the standard one. The length of the object is found to be in mm. Find the value of x. Okay, first of all, this is not in use, so it clearly encompasses that I can see there is no zero error. So because there is a no zero error, or there is slightly a zero error, there is slight error, there is an error. So this is a zero error here. First of all, from the data what I can make out that the least count of the main scale is equal to 0.1 centimeter, or you can say 1 millimeter, and the least count would be s minus v, that is sv is equal to what we can say 9 by 10 of s, so that comes out as s by 10 or 0.1 mm. And also because it has a negative zero error, we'll say this 9th division coincides, so error would be 10 minus 9, that would be 0.1 mm only. It won't be 0.9, it would be 0.1. Now check the reading. For the reading we have 1, 2, 3, 4, 5th division coincides, so that is 5 mm plus what we'll have the division which is coinciding. If you to see it carefully, what I can make out, the coinciding one, it's somewhat dubious. I am getting the result. It appears either this is the first one I am saying, that is basically the first one I that's look like. So its measured value would be, let's say this one, the first one is the more appropriate. Yes, so it is 5 mm plus 0.1 mm. So the measured value is 5.1 mm, but because of this zero error, the true value I'll add that zero error because with the sign opposite, so that would be 5.2 mm. So answer I am going to get is 5.2 mm or 5.20. You can write it like this. Next, the radiation emitted by the surface of the sun emits maximum power at a wavelength of about 500. Assuming sun to be a black body emitter, if the surface tension is temperature is alpha dot beta into 10 to the power gamma, fill the value of this. Okay, so what we will have, we know lambda mt equals b, so t is b 2.898 millimeter. Millimeter means 10 to the power minus 3 meter Kelvin, and this comes out as 500 into 10 to the power minus 9 meters. So meter goes. So cancelling after that, what we will get now, this is 9 and 2, this is 7 and 3, 4, 10 to the power 4, or better write it as 10 to the power 3 into 28.98 by 5 Kelvin. So what you will have now, if you do this, this will be 5.39 is 7, and then 48, it is 9 something into 10 to the power 3. So I can write in this form as 5.8 into 10 to the power 3. So 5 and 8 is 13, 13 and 3 is 16, so answer is going to be 16. Next one, in YDSE, how many maxima can be obtained if d is equal to 5 lambda by 2? So what we can say, the part difference at any point is d sin theta is n lambda. So the n value is d sin theta by lambda has to be less than d by lambda. So here d by lambda comes out as 5 by 2. So what we can get, n possible are 0, 1 and 2. So this is the central one, 1 corresponding we have 2 plus minus 1, and here also 2. So maxima that we will get is 5. So the 5 maximums can be seen here, not more than 5. This is a standard profile you must have done before. Now the last. Object of 100 grams moves in a circular path at a given instant. Velocity is towards I cap and acceleration is like this. So acceleration is along I cap also, there is c and at as well. So the rate of change of kinetic energy is, we know kinetic energy is half mv square. So rate of change of kinetic energy dk by dt would be written as half m into 2v dv by dt, and this dv by dt is not velocity derivative, it is speed derivative, so it would be mv into at. So what is m? M is 0.1, v is 10, and at is this one, the component along the velocity, that is 20. So it's going to be 20 meter, whatever will be the unit, it would be 20 joule per second, I can say. So it is 20 joule per second or kilogram meter square per second cube, whatever you can write. So answer is going to be 20, a nicely designed question. So that's all for today. Thanks for watching. Keep sharing the